Hi, welcome to Raw Math. Today I'm doing a series of videos on inverse functions. In this video, it says find the inverse of the following functions. Function. So I'm going to rewrite this as y equals the square root of 3x plus 9. And then probably my favorite thing to do is my first step, which is swap x and y before solving for y. So x equals the square root of 3y plus 9. To get the y out of this square root hat, I'm going to have to square both sides. So square and square. So x squared equals 3y plus 9. To get y alone, I'm going to, first I'm going to flip this around. So 3y plus 9 equals x squared. Subtract 9. 3y equals x squared minus 9. Then divide by 3. So I have the inverse of x equals x squared minus 9 divided by 3. Now, this is not really an inverse. And here's why. Bad line. This is graphed like this. This is graphed like this. And because it is a full parabola to this half parabola, this square root, they're not true inverses of each other. Only if I had done something like said x is greater than or equal to 0 and limited it, would it actually be an inverse. So you need to be really careful with functions like the square root of x and x squared when finding inverses to know whether or not they're true inverses. Because this, it looks like a parabola that's fallen over, but it's only half a parabola because there isn't a plus and minus included with it. So if I don't restrict this, then I don't really have an inverse. Now, if I added x is greater than or equal to 0, then yes, I absolutely have an inverse, but I need to include x is greater than or equal to 0 so I don't have the second half of my parabola, in which point I do have my inverse. All right, I hope you've enjoyed this video. Please subscribe to my YouTube channel, and I'll see you on the next video. Thanks.